Welcome back. Today we're going to be talking about factoring special cases. Now, special cases, factoring, we always look at if we can identify our perfect squares. So we're going to talk about the sum of squares and the difference of squares. Now, when we mean about a square, you think about a square. All right, it's same distance on this side, same distance on this side, and we multiply together. Same thing with our numbers. So I listed all of them in your Google Classroom, but I wrote them down here as well. So 1 squared is 1, 2 squared is 4, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 times 10 is 100. 11 squared, 11 times 11 is 121. You should know these ones in green. The ones in blue, maybe you're not too familiar with. I'm not asking you to memorize them, but you should know and be familiar with them. 144 is 12 times 12, 13 times 13, 14 times 14, 15 times 15, 16 squared, 17 squared, 18 squared, 19 squared, and 20 squared. Now, whenever we're looking to factor, if this last term ends up being a perfect square, there's a great chance that we can factor by one of these two methods. Not all the time, but a lot of times. There's a lot of perfect squares and difference of squares that we use in math. And it's a great way to save some time, especially when you're taking a test like the ACT. So we look to factor, just like we would before, x squared plus 18x plus 81. I know I'm going to start with x and x. Because both of these are plus, I know it's plus. And I know this 81 is 9 times 9. Or the square root of 81 is 9. Well, guess what? 9 plus 9 equals 18. There's our middle number. So this is a sum of squares. These are being multiplied together. Whoops, I don't want to do that. Now, a lot of times with mathematicians, we like to make things easy. I see here x plus 9 times x plus 9. Think about this. How could we rewrite, for instance, y times y? We would write this as y squared. Same thing here. We have the same thing times the same thing. So instead of writing this x plus 9 times x plus 9, we can write x plus 9 and then square this. Problem 2 down here. I recognize that 196 is a perfect square. So the square root of it, remember, the square root is the same thing as 14 times 14. So the square root of 196 is 14. If I add 14 up, I get 28. Now because this is plus and that's minus, instead of x plus 14, it'll be x minus 14. For both of them, and we can rewrite it as x minus 14 in parentheses squared. So the whole quantity is squared. Now, these are the ones that you're going to see quite a bit of, especially these. If you notice, these two problems look a lot different than the ones we've been doing. What's missing? Our middle term. There's no x's in these. It's just the x squared and then the constant. So you're like, well, what can I do there? Well, first of all, guess what? I identified that 64 is a perfect square and we are subtracting. So which means I need a positive and a negative. When you add them together, it equals, if there's no x's there, it has to equal 0. So if we take the square root of 64, if we make one number a positive 8 and a number negative 8, 8 minus 8 is 0. So this is how we would factor something without a middle term, and this being minus. X plus 8 and x minus 8. One's positive, one's negative. We cannot combine them like we did here because they're not identical. A great word for these are called conjugates. Remember that works. We're going to be using it. We're going to be using it later in the year. We're going to have to find conjugates. So if we look at the last problem, x squared, there's our minus sign, 289. Man, that's a weird number. How often do we see the number 289? Well, it's one of our perfect squares that we listed. So again, because this is minus, it's x plus a number, x minus a number. The square root of 289 is 17. And there's our factor. This will work every single time this is minus. If this is a plus, can't do it. Can't factor it at all. But again, I'm not here to trick you right now. Maybe later in the year or in the next class, we might be doing that to see what can be factored and what we can't. But right now, I'm not here to trick you. So it'll be 1 plus and 1 minus. See you next time.